the force, so the weight and the force upwards are like
Ooh.
from the hand.
All right, let me just give you a piece of advice here. We are assuming Jedi powers are not real. The force from the hand is long gone. So no force from the hand. If Jedi powers are real, you can make an argument for it, but we're assuming the metachlorians are very small in all this.
Is the ball in equilibrium at point C?
If it were in equilibrium, velocity would not change and it would hover.
Okay.
No, the velocity is changing. It is, I mean, Caleb's right. It is negative there. But it's because the only force acting on it is the weight, which is down. Gravitational force is always going to act down. Except on the small objects.
It's being like almost balanced out, because like when we were talking about like the velocity, it was like going from 10 meters per second to 0 meters per second.
Right.
That's a negative
Yes.
movement, even if it's at 0.
Yeah.
It's still in going in the negative.
Absolutely. And another way of looking at that, let's think about just that region right there. It's going to positive 5 to negative 5. So what's the change in velocity?
Negative 10.
So at point C, would it be correct to say that there's no normal force acting on the ball?
Oh, that is at C, that definitely.
Okay. Well, so just why? Why is normal force no longer acting on the ball at C?
Requires contact. What does it touch?
Okay. Okay.
That gets into Jedi powers. I could, I could touch it from a distance, but
Is there Star Wars physics?
I'm sure there is. Somebody's out there done physics of Star Wars. There's physics of Star Trek, but physics of chemistry of Harry Potter. I'm sure there's a physics of Star Wars somewhere. All right, so now we're left with just, let's have it A and F. So, at A, is it accelerating at A? It's not moving, but is it accelerating? Is the velocity changing at A?
Yes, because the hand is starting to move upward.
Yes. Yeah.
So it's good. It would it be positive?
Yeah. Because the hand's forcing up. And at F, F is the moment that it stops.
Is it negative?
Yes. Oh wait, no, not negative.
0?
Not 0.
So it has to be positive. Why is it positive?
Oh, because
Well, why?
it's going from negative like 10 meters per second to 0 meters per second.
That's one way of looking at it, yes. The other way of looking at it is what are the forces acting on it as you're catching it?
Normal force again, because you've got contact.
Backing up and,
Gravity. Weight, sorry.
so I got
Acting
those two
down.
forces. I've already passed the point where they're equal. It starts out where the weight is much bigger than the normal force when it first, that first moment it touches the fingers. But then they're equal, and then the normal force now is bigger than the weight. The net force is up, which is positive.
How did you explain it?
I was just thinking of it like the speed was going from, the speed of the ball was going from like negative, just going
Mhm.
down to 0 when you catch it.
That's a positive change.
Yeah.
I'm gonna nitpick one thing there. I mean, the way of looking at it, absolutely spot on. Velocity, not speed.
Sorry about that.
Yeah, man, early days. We've been in school, what, 3 months now? Yeah, 3 months, you should not be making that mistake. Come on, Ken. Other questions?
So how do we fill out the rest of the
Oh.
greater than, less than?
That's right. All right, so 0 was B and E. I'll just write B, E. We write the B so that it looks like a B. It is positive initially, so A, including A, to B, not including B. And it is also positive after E, E, F. And then, please note that just after time F, acceleration is 0. Acceleration is not big at time F, but it's still positive. And then It is negative between them, so it would be E. And again, on the test, there's 4 different ways of presenting the exact same information. Pick one. Or if you just like writing and got the time, please make sure you're consistent between different ways you present your answer. Any questions before we talk about lab?
Can you just explain acceleration again and like the difficulties with it? Because I feel like I'm understanding the first 3, but I feel like I'm struggling to understand the direction acceleration is going in.
All right, we can do it from a force point of view.
Mm-hmm.
That at A, it starts moving up. I got normal force and weight acting on this thing. If the normal force is bigger than the weight, my net force is up, so is acceleration. So from A to B, the normal force is bigger than the weight. That's why it's getting faster and going up. At some point, it's going to start slowing down. Well, that transition point is B. That's the point in which they're both equal. So because everyone loves the graph, of course. If that's the magnitude of my weight, my normal force at time A starts out bigger and then gets smaller. At some point it equals and then it drops off to 0. That's time B. So at B they're equal, so equilibrium. After that, the weight is bigger, so it's going to start to slow down. So my weight is dominant, my net force is downwards, negative. So that is what's happening, well, basically here.
Okay.
At E, well, sometime before, just before E, the hand touches it, but still you're not applying enough force yet. I mean, you can't go from, you have to go through 0 at some point. So normal force starts at 0. Eventually, I need more force upwards than downwards in order to stop it. Because if it's going that way, I need to apply more force upwards to slow it down.
Yeah.
And so in that last region there, the normal force outweighs it. The normal force is larger in magnitude than the weight because you're trying to stop it. So you need to apply a force that opposes the motion.
Okay.
Does that
That
make
helps.
better?
Yeah. Thank you.
Other questions? All right. I'm going to hand out the lab, then we're going to mosey on down to the other room. I'm going to point out a few things, or probably better. On your way out, grab a copy of the lab.